Thank you, thank you. Welcome everybody to my talk. It's all about the Java Cloud Native stack for microservices and serverless architecture. And I choose this title, and it's because of some years ago I was very confused about all of these buzzwords. So I did some research and did a talk about this. I'd like to introduce you to the Java stack, which is suited for microservices and serverless applications. And I will get started with telling you something you already know, and maybe I will tell you something you not already know so far. So my name is Markus. I am CEO, co-founder of MicroStream, and now I am founded a new company because everything is about AI. So I founded a company for building a vector database. I'm also editor-in-chief for the Java Pro magazine, and it's a free Java magazine. I will let some copies here so you can check it out. And you can also check out all the free articles online. And I try to be also very active in the Java community with my team. We've worked since 20 years on developer tools, database tooling, and mostly, not mostly, everything is open source. So we are also member of the Eclipse Foundation and run 3 Eclipse open source projects. And we are also a member of the Micronaut Foundation and contribute to Micronaut and to the project Helidon. And this is something about my background. All right, so let's get started with microservices in cloud. Who of you is building microservices already? Some, okay. Serverless applications or serverless functions. Okay, some. Okay, all the others maybe work still on monolithic applications, which is a good thing, actually. So everything started with the cloud, or not everything started with the cloud, but it was revolutionary when we started with cloud because it developed from physical servers to virtual machines, and then we get containers. So, and with containers, it was a cool thing. So then microservices were suddenly possible. So the microservice architecture came up. And actually, what is microservices? So here we have an architecture overview about a monolith. And in a monolith, we have, maybe we have modules, we have a lot of classes, we have functions, features. And so the idea is now to split the monolithic application into hundreds, sometimes maybe thousands of tiny services that run independently from each other in its own container, isolated, and to build applications that are more stable, more resilient in the cloud. They can scale horizontally, and the promise also is that you can develop your services in different programming languages, maybe, and so on. So there are many advantages in terms of microservices. So now the question is, when cloud, do it cloud native? What actually is cloud native? So it means, and it's important, if you use the cloud, you should use all the features that the cloud vendors provide you, not build your own stuff. This is the idea behind cloud native. And it's because of you will save, so you don't have to care for security, maybe because the cloud vendor cares for that. You don't have to care for scalability. You don't have to manage the service. So everything should be managed by the cloud provider. So this is a big advantage. So use what it's available in the cloud. And also use stuff that is built especially for the cloud. But with Java, we had some challenges when the cloud came up. So maybe you can remember. So why? And it's because there are some rules with microservices. So a microservice should be responsible for a single special task, different to a monolith. It should be very small, it should run its own container, and so on. And then there is also an interesting rule, if it deals with data, it should have its own database. And when we have a look on our traditional Java stack, with the JVM, with application servers, maybe there were some challenges. So we go through all this a little bit faster, because I guess this is something you already know. So here we have application servers. So who of you use still application server, by the way? Only some. Okay. So application server were built to run on a big server machine and to manage or to run multiple Java programs. But the problem is the startup time and the memory consumption of application servers. So, and then we have also challenges with our JVM. Then it's because of a microservice should start extremely fast, in milliseconds. So, in the startup time of the JVM, sometimes it's not fast enough, and it's because of it has a great JIT compiler. But we have challenges with the warm-up time. So as soon as the JIT compiler is up and running and optimizes your code and it's hot, so to say, then Java program is executed very fast. But the startup time is normally a little bit slow. So, and we have also challenges with traditional persistence and microservices. By the way, who of you has some challenges with persistence and microservices? No one. I will cut this part out of my session here. Okay, the application servers, they were replaced by microservice frameworks or micro runtimes. So we have two categories here. So we have the Spring. Who of you uses Spring Boot for microservices? Okay, a lot of people. And then we have the micro-profile compatible runtimes, like Quarkus. Who uses Quarkus? Okay. Then we have another standard, it's Jakarta EE, and now microprofile and Jakarta become more and more similar. So we have other frameworks like Open Liberty or Payara Micro, Helidon MP, which are microprofile compatible microservice frameworks. And then we have the more lightweight frameworks like Micronaut or Helidon SE. So this is the big overview about these micro runtimes. So, and they replaced the traditional Java application server. What about JVM? So there are also talks here at the conference about startup time of the JVM. So we have GraalVM for speed up the startup time of our JVM. By the way, this is not the JVM anymore. So if you use GraalVM to create a native image, then there is no more JVM, then you get a native code, a native executable. That's great because startup time will be faster, but there are also many drawbacks in terms of GraalVM native images. And I, of course, must ask the question, who of you uses GraalVM native images? In production? Okay, cool. But now there are also alternatives on the market. The JVM vendors, they provide functionality to avoid using GraalVM native images. So this is very innovative, and so you can keep your JVM, and you have a way faster startup time, achieve a faster startup time for your microservices. That's cool. So can we use it also with serverless functions. So what actually is serverless computing? So with serverless functions, you have a platform where the platform cares for your microservices, how they get started, when they shut down, and how they scale. Who of you uses something like AWS Lambda? Okay? So this is serverless computing, which means you can deploy your jar in a container, and then the infrastructure cares for your service, how it scales, and it's when it's invoked, when your Lambda is invoked and gets started, it executes the code and shut down. So and you don't pay anymore. You pay only as you go. So you pay just what you use. So this is very cost efficient, and so this is what serverless function brings on the table. So very innovative, but as I mentioned, the traditional Java stack was not suited for that. So, but now with all the new possibilities, with micro runtimes, with GraalVM native images, or with all the features you get from the JVM vendors, Java is great for microservices and for serverless functions. So, what about persistence? With persistence, we pretty much use the same concepts we use since 50 years. So even with microservices and with serverless functions. And so the question is this effective enough, or maybe is there an alternative? And with persistence, we have a lot of challenges. So let's jump into the challenges with persistence in general. So one of the biggest challenges with persistence is that Java as a programming language is completely incompatible with databases. So if you try to store an object in a relational database, maybe you will be not successful because it's not possible. So we have various impedance mismatches here because our object model is way more granular than the relational model. Subtypes is not possible in the relational model, and so on. So, and also the data types are different. So we have many challenges here when we want to store objects in a database. And it's the same actually with NoSQL databases, because the NoSQL databases, they introduce new data structure, but they are also incompatible with the Java object model. So we have similar challenges here as well. So these challenges are well known already since decades actually. So, but obviously the problem is solved because we can store objects obviously in a relational database, right? So yes, it is solved, but we need another layer in our application. We use object relational mapping framework like Hibernate. Who of you uses Hibernate or Eclipse Link? Okay, yeah, okay, cool. So what happens if you use Hibernate? So we worked on a Java IDE and on Hibernate tooling for Eclipse, and our users complained constantly because the performance is so slow. Then we introduced caching. So because caching can accelerate database queries, of course. So no worries, we can add a cache. And then you add complexity. So we talk about a single JVM application, a monolith. The complexity will increase with a distributed application. So if you run a distributed application, then the story goes on and on. So because now, what happens if the data is changed on one of your nodes. Then this node is in sync with your database. That's cool. The problem is all the other nodes are not in sync with your database. So, but we can solve this. And it's just change the cache strategy. You can now put your cache in between the application and your database. And a lot of people, they talk about costs in the cloud, right? So most people believe memory is very expensive. Who of you believes memory is very expensive in the cloud? No one. Okay, that's great. So this is what the question. I mean, of course, memory is expensive. But look what happens, what we are doing in practice. So memory is expensive, okay, but we use a cache in between because we need it. Who of you use distributed cache like Redis, for instance, Hazelcast, okay? So what you're doing, you add another machines where the cache is distributed and sharded through multiple machines. Do you use machines with low memory sizes? Obviously not. Makes no sense. So with a cache, you need a lot of memory, obviously. So you need a lot of more computing instances with a lot more memory to accelerate your database queries. Okay. So if the load increases on your database and you want to scale, a database, or you need high availability, then you need a more database machines. So the question is, do you save memory on your database nodes? I think this makes no sense. So the database will be using a lot of CPUs and a lot of memory, obviously, to be fast enough. And so when we have a look on the database system itself, then we can see it's a monolith. It's still a monolith. So we talk about microservice and serverless architecture, but when we talk about persistence, we use a monolith. So in monolithic software is not great in scaling. So this is the reason why a database is not great in scaling. So it takes time to start a new database node and also to scale down. And when you use a caching, distributed cache or in-memory data grid, then it uses sharding. And sharding by hashing means it will double or triple even your the resources you need in terms of memory and computing power, because all of your data is stored redundant on your server nodes. So you need 2 to 3 times more memory than you actually store with your data. And we can see our architecture gets more and more complex, but this is not the end. Who of you uses Elasticsearch or something like that? Okay, the question is to the database team, why actually using Elasticsearch? I mean, you have a database, and a database is built for searching, right? And with Elasticsearch or with a searching server in general, you add up more machines, you need a lot of CPUs and a lot more memory, right? So this is a big picture of an enterprise application, and then maybe you have multiple database systems. So because we deal with different data types, right? So with structured data, unstructured data, with complex data like a graph. So maybe you have a graph database. If you have unstructured data, maybe you have a MongoDB or other document-based database. And now you build something with GenAI, obviously, so you need a vector database, right? So multiple database systems. And if your manager will ask in the future a magic question why the cloud costs are skyrocketing. Now it's the time to take a photo, take a picture. This might be the reason. And it's just because we want to process data. Isn't this insane, actually? I think this is crazy. The question is there an alternative? And imagine we could build a persistence that fits to microservices. So similar as we changed the environment, so the runtime from application server, monolithic application server to micro runtimes like Quarkus or Spring Boot, or when we switched from the classic JVM to GraalVM native images, maybe we can also improve persistence for a microservice architecture. So imagine we would be able, this is the classic, so we have services and we have a monolithic database. So imagine we could now also split the monolithic database architecture into hundreds or thousands small storage services, each responsible for a specific task in just a specific part of your whole database, and connected to your services. Then you have a service that is responsible for a specific task, and it has its own storage. Now, the question is, if this would be possible, how should this work? And we have a solution. We have a solution built under the roof of the Eclipse Foundation, and it's called Eclipse Store. And with Eclipse Store, you will get an object graph storage engine that is able to store any kind of object graph, any size, any complexity, persistently on disk, without the need for object relational mapping and without the need to use a classic database system. Who of you has already heard about Eclipse Store before? Okay, cool. It is the development started almost 10 years ago. So it's an Eclipse project. It's open source. It's under the EPL license, and you can use it also for commercial purposes. So as I mentioned, it is a storage engine that can deal with any object graph, any complexity, any size. And to store objects, you just have to call a store method. To use Eclipse Store is very simple. It's just a Java library. You include it via Maven, and then you need an instance of Eclipse Store. It generates an object graph, or you design an object graph individually, and the only rule is there must be a root object, and then all objects that are reachable from this root object can be persisted, can be stored persistently on disk. And you just have to call a store method, and then the engine generates a binary representation of your object, of your object reference, and stores the binary persistently on disk. And when you start your service, then the engine will load the object graph in the memory, but only the object IDs. This is very cool, because it never loads your whole database into memory. It only loads the object references when you call a get method. So there are no more classic selects. You just have to call get method, and then the object reference is loaded, the subgraph is loaded, and is merged into your object graph automatically. It works like magic. When you store data, it is transaction safe. So this is an ACID compliant transaction. So it's full transaction safe. And you can choose your storage target freely. You can store your binaries on disk, on an SSD, mounted volume, whatever. And you can also use a blob store. So it's also recommended to use a blob store like AWS S3. The cool thing is, now let's reduce your cost. So databases in the cloud are very expensive in comparison. We don't talk about an enterprise database. Let's talk about a PostgreSQL. Here are some numbers from AWS, but it's just an example. So if you run a PostgreSQL just for CPU and some gigabyte memory, costs around $4,000 per year. It depends on the machine you choose. Maybe you can find a machine with just you paid just $2,000 per year for your server. Let's assume you pay just $1,000 per year. In comparison to false direction. In comparison to a blob store like S3, you can save more than 90% with a blob store. So I was talking about the 1 terabyte. And 1 terabyte S3 costs only $300. So you will save more than 90% by just using blob storage. So it's very, very cheap. Because it's just storage, and with a database server, you buy storage and compute in combination, and compute is more expensive or most expensive. So, and we have with Java everything we need to build fantastic applications and fantastic database applications. Why? And it's because we have a great performance. So, because of the our JIT compiler. So, everything you execute in memory with Java is executed in microseconds. Extremely fast. When we talk about the performance of a database, we talk about milliseconds. So it's 1,000 times faster when you can process a data operation in Java. And we don't have to talk about different data structure, unstructured data, structured data. You can deal in Java with both. What about graphs? Yeah, of course, we have object graphs. So we can also deal with complex data structure. And of course, with all data type, we can also deal with document. Everything is possible in Java. So we don't need 3, 4, 5 different data storage types. We just have Java. And we have a great query language for searching and filtering. We can use Java Streams API to process data in memory with pure Java. And this will be 1,000 times, so mostly, so between 10 to 1,000 times, depending on the use case. I'd like to show you a performance demo. This is a performance demo that shows there are 2 applications running. So it's a simple bookstore demo. 250 gigabyte of data, and the code is also on GitHub. You can check it out. 2 applications are running. One is built with a classic JPA stack. So one application uses Hibernate and EH cache, and a PostgreSQL database, 250 gigabyte. The other application uses just core Java stuff. So an object graph, Java Streams API for searching and filtering, and Eclipse Store for the persistence. In this demo, there is no persistence involved. This is the interesting thing. And it's because here we are reading data directly from a hot EH cache and compare it with searching an object graph that is also in memory. And the interesting thing is, it is sometimes 10 to 1,000 times slower just to fetch data from a hot EH cache. If persistence is involved, then the pure Java the pure Java approach is even faster. And it's because of databases are slow in comparison to just accessing a SSD drive. And with Eclipse Store, you just access a SSD drive or a blob store. Blob store is, of course, way slower, but it's your decision what you're using. And you get out the most of your JVM, of course. And a lot of people asking the question, yeah, okay, sounds interesting, but does this mean I serialize my objects directly to disk? Yes. Behind the scenes, Eclipse Store will serialize your objects directly on disk, and we use the Eclipse serializer for that. And it's because of you cannot achieve this with the Java built-in serialization. It is insecure, it is slow, it cannot deal with complex object graphs, and has many other drawbacks. So we developed the Eclipse serializer, which is also open source, and it can deal with any complexity of your objects. And the cool thing is, it's super easy to use. So there is no interface you have to implement. So no serial is able to implement. So it's very convenient to use. No annotations and so on. So really simple. And then there are a lot of drawbacks with just serializing objects to disk because, okay, what happens if my classes change? And so on. So schema migration. So imagine all your questions you will have in terms of just serializing objects to disk and recreating the objects in memory when needed. Imagine all your questions you have, all these problems are solved. What would you get? You get the powerful persistence engine you can use as a replacement for databases when it comes to microservice persistence. So it provides schema migration, it has a REST interface, it has a storage browser where you can browse the stored data on disk, and so on. Native backup functions, everything a database also provides you. This altogether is Eclipse Store. So now the question is, Eclipse Store runs in a single JVM. Is this a cool solution for the cloud actually? We started development of Eclipse Store when the monolithic architecture was state of the art. And we believe still today it's great, and it's a great use case. And it's because maybe not all of your servers are high available or have to be restarted in milliseconds. The question always is, if one of your services fails, is this mission critical? Will this kill your application? Will this kill your business case? If the answer is actually not, and it's because if it restarts in 2 seconds or in 500 milliseconds, we even don't care. We don't recognize even that the service was down. And today it's possible to start a microservice in 500 milliseconds. So then maybe you don't need a high available architecture. I don't want to say you shouldn't do that. So it's even better. But the complexity is way lower if you just start your microservices after some milliseconds and nothing happens. Nothing mission critical. If the answer is it is absolutely mission critical that the service is available constantly, then this is not a great approach. But the story does not end at this point. If you need a microservice that is highly scalable, high available, then you can use the next level, and it's called Eclipse Data Grid. With Eclipse Data Grid, now you get a highly scalable Eclipse Store service that is horizontally scaling It provides replication, and you can now build horizontally scalable microservices that use Eclipse Store as a persistence. And then the architecture will look like this. So you have your services, you have Eclipse Data Grid in between, and Eclipse Data Grid feels like AWS Lambda. You can just deploy your jar, you build your single JVM single JVM service. That works great for a single JVM microservice. You deploy it in an Eclipse Data Grid, and it can scale. You just have to define how it should scale. So through how many nodes would you replicate your object graph? How should the behavior be of your nodes? So when should the node start? How many nodes should be started? When should the node shut down? So you have elastic scaling. You can configure that freely and very easy through graphical user interface. And the Eclipse Data Grid also is completely open source under EPL, and you can use it for commercial purposes. So now you can use Eclipse Data Grid as a persistence layer for your microservices, but you also can use it for pushing all the complexity into a Java layer. So imagine you have very complex PL/SQL code in Oracle database. Maybe you have very complex data structure in a graph database. You have to deal with document data and so on. Yeah, you can use the traditional architecture stack, of course. Remember this picture, but you can also now move all the complexity into a Java layer and reduce storage to a primary database. And even this primary database can be relieved because you push all the complexity into a Java layer. We can deal with Java in a better way, more elegant and faster. We have a better performance in Java. Everything that's executed in memory with Java is extremely fast. And you can make your database team happy because you keep your traditional database for maybe transactions, if this is important for you. In this layer, now you can use it for caching, but it's way more than caching, because this is not just a cache like the caches, the key value stores. You can use it for in-memory searching, extremely fast with just Java Streams API, so you don't have to learn another query language. It provides you indexing. So, because you don't want to search a ton of data on a hard disk drive and load it into the memory, so you have indexing. And the cool thing is you even don't need to replicate all of your data through multiple JVM nodes. It is way faster to store data on disk and to fetch data from a SSD drive. It will be faster than retrieving data from a cache node, because SSD is faster. So you can keep just 20% of your hot data in memory, and you load object references from hot disk drive, and it will be faster than loading data from a distributed cache. So, and if you, in some cases, if you really don't need the monolithic database server anymore, you can even skip your monolithic database server, and it's because it provides you persistence already, and then, but maybe you have to discuss this with your database team. And at the same time, this is one of the biggest drawbacks of this solution. If you really want to skip the database because of it is faster, it saves a lot of money. The drawback is your database team will not be very happy. So it ends up in discussions. So it's on you, and mostly we suggest just to keep a primary database, but you can rethink all the other solutions you use today, and which cost a lot of money. And you can see also we remove a lot of machines, a lot of costs, and yes, of course. It is an in-memory technology. We need memory. It makes no sense to use it with low memory. And memory is expensive, but we take memory away from a lot of server machines we don't need anymore. And the cool thing is with Eclipse Store, you can even run it with small memory sizes because we have lazy loading. You never load the whole database into the memory. So here's the big picture. Java is very powerful. We can deal with everything. The problem is persistence is missing in Java. And with Eclipse Store and Eclipse Data Grid, now we add persistence to Java, Java native persistence. You get indexing, you get lazy loading, a locking API, even transaction safety, a cluster infrastructure for microservices, and yeah, best possible performance on the planet. And you will win every single performance contest against a database team. I promise you, because it's the performance of Java and not the performance of Eclipse Data Grid. So if you'd like to learn more about Eclipse Data Grid and Eclipse Store, we provide free courses. You can check it out. You can find the code on GitHub. I jump over these slides because I ran out of time. Now we work on vector search, of course. We had also a vector search, but the Java native vector search. And here you can register for a free online training. So we provide through Java Pro free online training for Eclipse Store and Eclipse Data Grid. You can enroll for free and yeah, check it out. If you have any questions, then reach out. We are happy for answering questions. Yeah, thank you for joining. If you have questions, I'll be here for some minutes. Thank you for joining and have a great day at Fox Days in Thessaloniki. Thank you.